Good morning, class. So, in the previous class, we have started the chemical bonding and the introduction part we have done in that video. So, today in this video, we will move forward and we will start with Causal's theory in terms of chemical bonding. As I've told you that Causal and Lewis were the two scientists, those have given the theories due to with the help of that theories we can come to the conclusion that what is the actual cause of chemical bonding. Now what Cossel has said in his theory, he has said that we all know that in periodic table the highly electronegative halogens are placed on the right and the highly electropositive alkali metals are present on the extreme left. All the alkali metals, those have the tendency to lose the electrons. Those are in left, and the halogens, those have the tendency to accept the electrons. They are at the right, and in between that, like halogens are 17 group, and alkali metals first group. So in between 17 group and first group, there is 18 group which contain all the noble elements, and noble elements have the noble gas electronic configuration, means their outermost shell is stable, so they do not react, they are very less reactive. On the other hand, halogens have the very high tendency to accept the electrons, and alkali metals have a very high tendency to lose the electrons. So halogens gain an electron and form a negative ion, while alkali metal lose an electron to form a positive ion. And this losing and bonding, losing and gaining, create a bond due to which they both can join together and form the chemical bonds, and this is called as chemical bonding. This is a type of chemical bonding, we can say. So the negative and positive ion formed can attain a noble gas electronic configuration, means if alkali metal will lose one electron, they will get the noble gas electronic configuration, and if halogen will accept one electron, they will also get an noble gas electronic configuration. So the noble gases, with the exception of helium, which has a duplet of electron, have a stable outer electronic configuration of 8 electrons, that is octet. So this is the base of formation of chemical bond, we can say. And the atoms can also acquire noble gas configuration by sharing with other electrons also. Means the atoms can acquire the noble gas electronic configuration either by sharing or by losing or gaining the electrons. So on the basis of that, we are having different type of bonds, that are ionic bonds and covalent bonds, and there are other bonds also, about which also we will study in our next classes. But right now we will see that here, suppose nitrogen is having one extra electron, and chlorine require one electron. So if nitrogen lose one electron, chlorine can gain that one electron. So when nitrogen will lose one electron, it will become sorry, not nitrogen, if sodium will lose one electron, it will become a cation, that is Na plus, and that electron which sodium has lose, that chlorine can accept that electron, and chlorine can become a anion, that is Cl minus, and then both these cations and anions will join together due to the electrostatic force, because they both are having the opposite charges. So opposite charges will attract to each other, and a force of attraction will develop in between these two atoms, in these two ions. With that, force is called as forces of attraction, and ultimately NaCl will form. Here Na is also getting the noble gas electronic configuration, and chlorine is also getting the noble gas electronic configuration with the help of this bonding. Clear? So in this way, we can form the different bonds. With the help of these bonding, the electrons can attain their noble gas electronic configuration. Now, electrovalent bond and the octet rule. The bond which is formed as a result of electrostatic attraction between the positive and negative ion, as I have told you, that is the electrovalent bond. And the electrovalence is thus equal to the number of unit charges present on the ions. So due to this, what will happen? What we have said, that electrons form the bonds to, the first reason is to attain the noble gas electronic configuration. So in the formation of NaCl, this is proved. Yes, Na and Cl are forming a bond, which is electrostatic bond, and due to this bond, both are attaining the noble gas electronic configuration, and this was only the octet rule. ऑक्टेट रूल में यही तो बोला था ना कि कोई भी जो एलिमेंट है वो कंपाउंड क्यों बनाता है, टू अटेन द नोबल गैस इलेक्ट्रॉनिक कॉन्फ़िगरेशन। एंड NaCl जो हमने देखा जो कंपाउंड बनाया उससे ये बात प्रूव हो जाती है कि यस ऐसा ही है। So now what we are saying now, there are two types of bonds basically, that is ionic bonds and covalent bonds. So first we will study about ionic or electrocovalent bond. What are these bonds? Electrovalent or ionic bond is formed between the atoms by the transfer of one or more valence electrons of one atom to other atom, so as to complete their outermost octets and acquire stable nearest noble gas configuration. Like sodium and chlorine has attained the stable electronic noble gas configuration. जो सोडियम था उसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन कौन से एलिमेंट के बराबर हो गया था? सोडियम का इलेक्ट्रॉनिक कॉन्फ़िगरेशन हो गया था आफ्टर लूजिंग वन इलेक्ट्रॉन 10, है ना? और 10 किसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन होता है? 10 इज द सॉरी एटॉमिक नंबर होता है। 10 इज द एटॉमिक नंबर ऑफ नियॉन। तो इट मींस सोडियम का जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन है वो कैसा होगा? नियॉन वाला हो गया, 2s2 2p6। ऑन द अदर हैंड अगर हम क्लोरीन की बात करें तो क्लोरीन का एटॉमिक नंबर होता है 17 एंड क्लोरीन हैज एक्सेप्टेड वन इलेक्ट्रॉन इन दिस बॉन्डिंग। तो क्लोरीन के पास 18 इलेक्ट्रॉन हो गए। तो क्लोरीन का जो नियरेस्ट नोबल गैस था वो था आर्गन। आर्गन का एटॉमिक नंबर 18, क्लोरीन का भी 18 हो गया इस फॉर्मेशन से, और क्लोरीन को 3s2 3p6 का इलेक्ट्रॉनिक कॉन्फ़िगरेशन मिल गया। क्या? तो ये हमारा इसमें हमने देखा। तो अब हम क्या देखेंगे कि the electrostatic force of attraction which holds the oppositely charged ions together is known as a ionic bond or electrovalent bond. The compounds containing ionic or electrovalent bonds are called ionic or electrovalent compounds, like NaCl is an electrocovalent compound, and CaF2 is a electrocovalent compound, MgO is a electrocovalent compound. So there are so many compounds which exchange their electrons, and in this way the force of attraction will develop in between them, and due to this force of attraction they will get bond with each other, and this is the chemical bonding. Now what are the factors which affect the ionic bonds, or you can say what are the factors which are required for the formation of an ionic bond? अगर आपको एक ionic bond बनाना है तो two types के bonds है हमारे पास, है ना? Covalent bond and ionic bond. So one by one we will study the properties of these ionic and covalent bonds in detail. एक एक करके हमें क्या करना है, डिटेल में पढ़नी है इनकी प्रॉपर्टीज को। Clear? So first we will start with ionic compounds or the ionic bonds, कि क्या इनकी properties हैं and what are the conditions required for their bonding. Okay, so the first condition which is required for the formation of ionic bond is ionization enthalpy. We know what is ionization enthalpy. Ionization enthalpy is the amount of energy required to remove the most loosely bonded electron from an isolated gaseous atom to form a positive ion. See students, क्या होगा जब ionic bond बनेगा? तो जब ionic bond बनेगा तो ionic bond बनने के लिए सबसे पहले कैटायन का बनना जरूरी है ना? देन एनायन का बनना जरूरी है, एंड देन दे बोथ विल जॉइन टुगेदर विद द इलेक्ट्रोस्टैटिक फोर्स. So the first step is formation of cation. So formation of cation जब हो रहा है, it means one electron is losing, and when electron is losing, or when we require to lose one electron from the outermost shell of any atom, so we need to give the energy. This we have studied in the previous chapter also. Chapter 3 में आपको मैंने बताया था ये चीज, and that energy is called as ionization enthalpy. Clear? Suppose Na से मुझे Na plus बनाना है, तो I required some energy, and that energy or that enthalpy is called as ionization enthalpy. So the lesser the ionization enthalpy of an atom, the greater is the ease of losing the valence electron. No, जितनी कम होगी ionization enthalpy, हमें जितनी कम energy देनी पड़े, उतनी easily इलेक्ट्रॉन जो है वो लूज हो जाएगा, बिकॉज हमें ज्यादा एनर्जी अरेंज नहीं करनी पड़ेगी, थोड़ी सी भी एनर्जी है तो वी विल गिव दैट एनर्जी. मतलब जितना इजीली जो आउटर मोस्ट इलेक्ट्रॉन है वो लूज होगा, उतना इजीली कैटायन का फॉर्मेशन होगा. क्लियर? So that is why metals have a low ionization enthalpy. We know that. So they have the greater tendency to form the ionic bonds. like alkali and alkaline earth metals, which have relatively low ionization enthalpy. So they generally form the ionic compounds because their ionization enthalpies are low, so they easily lose the electrons and form the cations. Now cation has been formed. Now the second step is the formation of anion. Clear? Formation of anion means we need to add one electron in the outermost shell, and we know the electron gain enthalpy is the amount of energy released when an electron is added to an isolated gaseous atom to form a negative ion. This also we have studied in chapter 3. So now because we are adding one electron, so some energy will release. पता है आपको कि जब हम इलेक्ट्रॉन को ऐड करते हैं तो एनर्जी जो है रिलीज होती है, and that energy is called as electron gain enthalpy. So higher the value of negative electron gain enthalpy, greater will be the ease of formation of anion, because as I've told you that energy is inversely proportional to the stability. तो जितनी ज्यादा से ज्यादा एनर्जी रिलीज होगी while adding the electron, उतना ही हमारा जो आयन बनेगा that will be stable और उतना ही easily बनेगा वो, है ना. तो जितना ज्यादा नेगेटिव होगी वैल्यू इलेक्ट्रॉन गेन एंथैल्पी की, नेगेटिव मींस जितनी ज्यादा हाई वैल्यू होगी इलेक्ट्रॉन गेन एंथैल्पी की, उतना ज्यादा इजीली anion का formation होगा. So in general the elements which have high electron gain enthalpy form ionic compounds. For example, halogens and oxygen group elements, they mostly form the ionic compounds because they have the very high electron gain enthalpy. Is clear? Now the next thing is what? Now the formation of bond has to take place. We are having cation also and anion also. The formation and strength of an ionic bond also depend upon the electrostatic force of attraction between a positively charged ion, because both are having the oppositively charged charges now, so they both will attract to each other, and this attraction is electrostatic force. और जितना ज्यादा ये attraction होगा bond जो है वो उतना ही ज्यादा strong बनेगा, है ना. So due to the strong electrostatic attraction between the ions, formation of the crystal results in the release of energy. The amount of energy released when free ions combine together to form one mole of a crystal is called lattice enthalpy. अब ये जो हमारे ions बने, students जब ions आपस में जुड़ते हैं, then also energy will get released. And that energy जब bond formation हो रहा है और energy release हो रही है, तो क्योंकि ये जो हमारे जितने भी metals हैं, ये हमेशा जो structure बनाते हैं जुड़ने के बाद, उसे lattice बोला जाता है. So that is why this structure, this energy is also called as lattice energy or lattice enthalpy. So this is a new definition which I am telling you. The amount of energy released when free ions combine together to form one mole of a crystal is called as lattice enthalpy, and it is denoted by U. So higher the value of lattice enthalpy, greater will be the ease of formation of ionic compounds, same as that electron gain enthalpy. जितनी ज़्यादा energy release होगी, compound जो बनेगा वो उतना ज़्यादा stable होगा और उतनी easily बनेगा. So it means what we can say कि अगर हम कोई एक ionic bond बनाना चाहते हैं, so the ionization enthalpy should be low and electron gain enthalpy should be high and lattice enthalpy also should be high, है ना. तो ये तीनों चीजें हमारी क्या होनी चाहिए? हाई होनी चाहिए. इलेक्ट्रॉन गेन enthalpy जो है वो क्या होनी चाहिए? पॉजिटिव होनी चाहिए. इलेक्ट्रॉन गेन enthalpy should be negative and lattice enthalpy should also be negative because energy is releasing. Clear? But students, the ionization process is always endothermic, means absorbs the energy, while electron gain enthalpy process may be exothermic or endothermic. This also we have studied कि जब कभी इलेक्ट्रॉन जो है easily add नहीं हो पाता, तो उनकी इलेक्ट्रॉन गेन enthalpy जो है वो कैसी हो सकती है? पॉजिटिव भी हो सकती है. लाइक हमने देखा था नोबेल एलिमेंट्स, वो तो इलेक्ट्रॉन को एक्सेप्ट ही नहीं करते. तो नोबेल एलिमेंट्स में अगर हमें इलेक्ट्रॉन को जबरदस्ती एंटर करवाना है तो हमें एनर्जी रादर उसके की एनर्जी रिलीज हो, एनर्जी देनी पड़ती है. सो इन दैट केस एनर्जी कैन बी positive also, है ना. तो it's may be endothermic and can be exothermic also. Lattice enthalpy is exothermic, means because energy is releasing, है ना. So now if the net effect of the above three factors, that is ionization enthalpy, electron gain enthalpy and lattice enthalpy, is the release of energy, then ionic bond will be formed, है ना. So this is in accordance with the general observation. तो क्या होना चाहिए हमारा? जो net इसकी energy आनी चाहिए, जो तीनों को अगर हम ज्वाइन कर लें, आयनाइजेशन एंथैल्पी को, इलेक्ट्रॉन गेन एंथैल्पी को और लैटिस एंथैल्पी को, दैट शुड बी नेगेटिव. अगर वो नेगेटिव है तभी बॉन्ड का फॉर्मेशन होता है, अगर वो नेगेटिव नहीं है तो बॉन्ड का फॉर्मेशन नहीं होगा. ठीक है. टू फॉर्म एन आयनिक बॉन्ड, द सम ऑफ ऑल these should be negative. That is, release of energy should be there. Then only the formation will take place. Yeah. Now, about lattice enthalpy, I just want to tell you a few things. Amount, as I've told you, that amount of energy required to break 1 mole of crystal in this case will also be the lattice enthalpy. लेटिस एंथैल्पी हमारी क्या होती है कि जब बॉन्ड का फॉर्मेशन होता है तो जितनी एनर्जी रिलीज होती है दैट इज एंथैल्पी. बट जब बॉन्ड टूटता है तो उसके लिए हमें जितनी एनर्जी देनी पड़ती है दैट इज ऑल्सो कॉल्ड एज लेटिस एंथैल्पी. बट डिफरेंस क्या है दोनों में कि व्हेन द फॉर्मेशन ऑफ बॉन्ड इज टेकिंग प्लेस एनर्जी विल बी रिलीज्ड, है ना. मीन्स एक्सोथर्मिक होगा, मीन्स नेगेटिव होगी एनर्जी. यू विल बी द वैल्यू ऑफ यू विल बी नेगेटिव. एंड व्हेन बॉन्ड इज ब्रेकिंग, जब बॉन्ड टूट रहा है तो हमें एनर्जी देनी पड़ती है एंड एट दैट टाइम द लेटिस एंथैल्पी विल बी पॉजिटिव. ये बात आपको याद रखनी है क्योंकि स्टूडेंट इसके लिए कंफ्यूज हो जाते हैं कि लेटिस एंथैल्पी जो है वो नेगेटिव होती है या पॉजिटिव होती है. सो व्हेन द लेटिस एंथैल्पी इज amount of energy required to break 1 mole of crystal, in that case the lattice enthalpy will be positive. And when the lattice enthalpy is the amount of energy released when free ions combine together to form 1 mole of crystal, in that case lattice enthalpy will be negative. Clear? So what are the factors affecting on lattice enthalpy? As about ionization enthalpy and electron gain enthalpy we have already studied in chapter 3. But what about lattice enthalpy? So lattice enthalpy is also inversely proportional to the size and proportional to the intermolecular distance. Clear? And charge, more the charge on the ions, more will be the lattice enthalpy. Clear? So these are certain factors about lattice enthalpy. Now, some of the general properties of ionic bonds. We all know that ionic bonds are formed due to electrostatic force of attraction, which is a very strong force of attraction. So these generally exist in solid shape. Okay, their melting and boiling points are very high because of strong electrostatic forces. If we talk about their solubility, so in chemistry, this is a rule that like dissolves like. So all the ionic compounds are soluble in water because water also have slight charges and it is polar solvent. About polarity also we will study in this chapter further, but insoluble in organic solvents. Electrical conductivity, so they all are good conductors because free ions are there and ions can move from one place to another and can conduct the electricity, so they all are the good conductors. If we talk about the direction, so they all are non-directional. Clear? So they, it means they do not direct towards any coordinate. Clear? So these are some of the properties of ionic bonds. So in the next video I will explain you about the covalent bonds. Clear, students? Thank you.